Alright everybody, welcome back to Alex Does Lead Code. Today, once again, as usual, we're going to be tackling a lead code problem. We're going to have a new problem today. I think. Yeah, we're going to have a new problem today. We have tried a few different problems over the past 2 weeks. We were stuck a little bit last time around. And this time we're going to pick something random and see if we can tackle that. Alright, let's do a medium one. Actually, let's do an easy one because I might have to go halfway through the stream. We have to cut today's stream short a little bit. Dynamic layout, no, I don't. Alright, so let's look at what this problem is about. This is, again, lead code 75, problem 1732, find the highest altitude. So we can start, as usual, by reading our requirements. This is good practice, not just when you're tackling these clinical academic problems. But this is really good practice. Reading your requirements very carefully is also really good software engineering practice when you have a real software engineering job. Because what people want can be very different from what you think they want. Sometimes they might want things that you think they should not want, and sometimes they want things that are kind of stupid, honestly. So reading your requirements first, making sure you're crystal clear what the requirements are, is a great way, it's a great habit to build when you're programming. So let's look at the problem. Find the highest altitude. There is a biker going on a road trip. The road trip consists of n plus 1 points at different altitudes. This is kind of funky to me. I'm not sure why n plus 1. Okay, the biker starts with point 0 with altitude equals 0. You're given an integer array gain of length n, where in I is between I and I plus 1. I see. So you start at 0, and then gain I is the gain from point 0 to point 1. 0.0 to 0.1, and so the last point that you represent will be point n. So the reason why this is n plus 1 for an array of n size n is because the gain is between any 2 points. It's basically an interval between 2 points. Okay, so it's net gain between I and I plus 1 for all. Return the highest altitude of the point. Okay, so let's go to a worked example. Alright, worked example. Let's take this one. 1, 2, 3, 4, 5. There are 5. There are 5 gain values indicated, which means actually there are 6 different points. Right, because the gain is the distance between each of these axes. Okay, so we can actually do this like nice graphically. So let's start. The first gain is so we assume they start at 0. So let's say this is point 0. Okay, the first gain is actually negative, so it's negative 5. 1, 2, 3, 4, 5. Let me see if I can do this. Python will not like me for doing this. Okay, so the first point is here, is down here. And this point is at minus 5. And we know that because point 0 is at 0 and the first point, point 1, is at minus 5. Okay, point 2 is 1 above point 1. Now, it's very important to be clear that this point is not point, this 1 here. Let's copy this gain here so that we can all see it better. So it's not blocked by my stupid face. Yeah, okay. Face not blocking anything. Great, good job, face. Well done. So it's important to note that this 1 doesn't mean that this x here is at altitude 1. It means it's 1 more than the previous guy, which is this guy. And that previous guy was at altitude 5. So this x2 is actually here. And its altitude is -4. It's one more than the previous one. x3 is now 5. And how do you get -4? Well, we added 1 to -5. Right? x3 is now 5. It's this one right here. x3 is now 5, which means it's 5 more than the previous one at -4. So where is x3? Well, this means that x3 is going to be altitude 1. It's at altitude 1. And then x4, between x3, between this and this, there's 0 difference. So this guy is also at altitude 1. And then last one is at altitude -7. So 1 minus 7, this will be at altitude -6. All the way down here, x -6. So this is what it looks like. You can imagine a mountain that goes down, then go up, and then go down like this. So the question asks us to find out which is the highest point. Oh, sorry, it doesn't ask us to find out, you see? Important not reading the question. It asks us to find the highest altitude of any point. The highest altitude of any point. Now notice that we actually have 2 contenders. So these 2 guys are actually at the same height. Okay. In this case, normally if we are asked to find out which point is the highest, then we need some mechanism to disambiguate and pick one of them. Right? Since they're the same height, we need to figure out who is higher. But in this case, our question is asking us to return the highest altitude. We just need to say the highest altitude is 1. We don't care which one of these points actually manifested altitude. Alright, so how do we do this? Well, we've probably done this question in the past where we find the highest possible integer, right? We are given a list, find. Oh, why are we in C++? Good Lord. Good heavens. Sweet baby Jesus. No, baby Jesus, you have let me down. Okay, great, thank you. Okay, back to sanity. Alright, we have done a problem before where we're given a list and we want to find the largest number, right? So the way we did this was to keep track of the highest number we have seen so far. Okay? And then return that. Now, this strategy, we're going to solve today's problem using a modified version of this strategy. We're still going to keep the highest, and it's going to be at 0 initially, because the starting point is 0. But the difference is, now instead of looking at the value of each integer, we have to calculate what the next altitude is. So for that, to calculate what is the altitude of any particular point, we need its gain and its previous point. We don't need all the points before it. We just need the one before it. We can call it past altitude. The last altitude, let's just say 0. Okay, and now what we want to do is want to say for gain in gain. Oh, this is not great. G in gain. We calculate current altitude equals to last altitude plus G. So we add our current gain. If the previous altitude is 0, our current altitude at here will be 0 minus 5. 0 plus negative 5. And that will give us our current altitude of minus 5. And we also say last altitude equals current altitude. This step is very important and we'll show you later. And now what we can do is we can check if this altitude is the new highest. If current altitude, so actually you can just do something that Python likes a lot. We say highest equals maximum of highest and current altitude. So we'll pick the higher one. Now, this step is very important. Okay, let's run this first. I'm fairly confident that this would be the correct solution. Oh, sorry, I'm not confident at all. I need to return highest. Let's run it. Okay, case 1, case 2, they both work. Let's submit it. Beats users with Python 3. So I've realized actually, this is actually funky. So I've realized that this is not users with Python 3. This is beats 33.8% of all users. The reason why this is so low is because we're getting compared to C++ users, who obviously have an unfair advantage. But also, I'm not sure. I've seen mixed reports. I feel like it's also possible that people have better hardware than me. And that's why their program is faster than mine. But all that's all conjecture. I do have a fairly powerful gaming machine. Okay, alright. So I'm pretty sure this is the correct answer. Now, why is this line important? What happens if we take this out? Okay, current altitude equals last altitude plus G. If we take this out, then last altitude will almost remain at 0. Yeah? When you want to calculate the altitude of this x here, you need to take minus 5 plus the gain, which is 1. You can't take 0 plus gain. If you do that, then at the point at index 2 will end up here, which is not what you want to do. Okay, other than that, I think this is a fairly straightforward problem, and I think we're going to close up early for today. Thank you everybody for watching, and see you next time.